Greetings and good time of day to you. If you've recently obtained or discovered hidden away one of these, or one of these, that you are not certain is in working order, then there are some simple tests you should carry out before switching it on. This may avoid you causing it any further damage should it be faulty, though I won't say much today about how to repair any of the faults you may discover. These tests are appropriate for all 48K spectrums, but not any of the 128K models. All you need is a very basic multimeter that is able to measure resistance. Like this one. Turn the spectrum upside down and remove the screws. Then, holding the two case halves together, turn it back the right way up. You can now lift the upper case off, but slowly. If you are lucky, you will find two flexible keyboard connections tethering the top half of the case to the circuit board. If you are unlucky, they will have disintegrated due to old age, or will do so as soon as you try to unplug them. Fortunately, new keyboard membranes are available, so don't worry if yours is broken. If the keyboard is still connected, grip each flexible tail in turn close to where it enters the connector on the circuit board and pull it firmly straight out. Put the upper case to one side. Some of the components inside the spectrum can be damaged by static electricity. There's no need to take extreme precautions, but don't do this on a nylon carpet. If your spectrum appears to have its original electrolytic capacitors, as this one does, I recommend they be replaced with new ones. Their age means their reliability can't be trusted, and I've seen many spectrums that have failed because of capacitor faults. Even if the originals still work, replacing them will probably improve the quality of the television picture. The tests I'm about to show you are to check for faults in the spectrum's power supply related circuits. If these are faulty, then it's certain the spectrum won't work. In particular, the first 16 kilobytes of the spectrum's RAM are provided by these 8 dynamic RAM chips. They require 3 different power supply voltages, 5 volts, -5 volts, and 12 volts. If any of these are missing, the RAM chips are likely to be permanently damaged. By measuring the apparent resistance between various points on the circuit board, it's possible to detect many of the common power supply related faults. Note that because the circuit paths you will measure are not pure resistances, they contain semiconductor junctions and capacitors, the readings are likely to vary depending on the meter used and the range it is set to. If you have another spectrum that you know is in good working order, it may be useful to compare readings between the two. Nevertheless, most meters should be able to tell you what you need to know, and for most of the tests, a resistance reading much lower than expected indicates a problem. This multimeter has manual range selection, but one with auto ranging should work as well. Set it to measure resistance. I'm going to start off with this one on its 400 kiloohm range. Connect the common terminal of the meter to the metal tab of the 7805 voltage regulator, or to the heatsink next to it. The voltage regulator is in the top right-hand corner of an issue 3 or later spectrum, or further down on the right-hand side if it is an issue 1 or 2. Hold the probe firmly in place, or use a lead similar to this one to connect it. Make sure it doesn't come into contact with any other part of the circuit board. For the first test, press the other probe firmly onto the left-hand terminal of the voltage regulator. It is normal for the meter to give a reading of a few kiloohms, rapidly increasing as the input filter capacitor charges. After a few seconds, the reading should be over 100 kiloohms. If the meter indicates open circuit, that's probably fine too, but make sure the test probes are making good contact. However, a reading of less than 100 kiloohms often means the voltage regulator is faulty, though there are other possible causes. Assuming that test went well, leave the meter's common terminal connected to the heatsink and choose any one of the 8 RAM ICs in the lower left-hand corner. Touch the free probe to the upper rightmost pin. This should be connected to the 0-volt power supply rail, and so the meter should read 0 or very close to it. If it doesn't, either one of your probes isn't making a good connection, or there is a broken track on the circuit board. Now move the probe to the RAM chip's lower right-hand pin. This is the 5-volt connection. This meter shows 0.3 kiloohms or 300 ohms. Some may give a higher reading. If you get a value much below 300 ohms, then something is wrong. Next, hold the probe onto the upper leftmost pin. This is the minus 5-volt connection. On the 400 kiloohm range, this meter starts off with a reading of a few tens of kiloohms and rising. But switching to the 400 ohm range gives just under 300 ohms. This dramatically shows how the reading may vary depending on the different test voltages applied by the meter on its various ranges. But this doesn't matter, and as in the last test, if you get a reading of much less than 300 ohms, then there's probably a fault. The final power supply connection to the lower 16K of RAM to test is the 12-volt one. This is the lower left pin. I found that most meters on most ranges give a reading of 2.6 to 2.8 kiloohms for an issue 3 or later spectrum, and 800 to 900 ohms for an issue 2. Again, if you get a reading much lower than the relevant range, your spectrum is probably faulty. Disconnect the probe from the heatsink. Notice the inductor coil over here. It has 2 windings, and it is part of the circuit that generates all of the voltages, other than 5 volts, that the spectrum needs. Its connections are a useful place to make some further checks. The spectrum circuit board should be held in place by a single small screw. Remove this and take the board out of the plastic case. Turn the board over and find the solder pads where the inductor is connected. These 2 points are either end of one winding, and these 2 either end of the other. The DC resistance of each winding, as measured by the multimeter, should be very low, close to 0. This meter beeps to indicate a low resistance. If you measure a higher resistance or open circuit, then that winding has probably failed. Auto-ranging meters sometimes become confused when measuring the resistance of an inductor. If this happens, you should manually select a resistance range. Now check the resistance between the 2 windings. The meter should indicate open circuit or a very high value of at least several megohms. Because the windings are inductively coupled, you may briefly see some other value when you first connect the probes. Ignore this. Try with the probes the other way around too. Any low reading here may mean the insulation on the windings has failed and they have shorted together, but it's more likely transistor TR4 has failed with the short between its collector and emitter. If you've reached this point without uncovering anything wrong with your spectrum, there's a good chance it has no disastrous faults, but there are a few more tests it would be a good idea to carry out, provided your multimeter has a diode test function. Identify transistors TR4 and TR5 on the circuit board. They are here and here on an issue 2 spectrum, and next to each other here on other spectrums, apart from the issue 4S, which I'll talk about later. I'm using these grabber test probes because they are easier to connect to the transistor's legs. With the meter set to the diode test mode, connect the positive terminal to the center leg of TR4. This is its base. The other 2 legs are its collector and emitter. Touch the other test probe to each of these in turn. In both cases, the meter should display a reading in the range of 0.6 to just over 0.9 volts. Make sure your test probes contact only the transistor leg they are supposed to, and not each other, as not any nearby PCB pads or tracks. Now connect the negative probe to TR4's base in place of the positive one, and repeat the last test with the now free positive lead. In both cases, the meter should indicate an open circuit. Move on to transistor TR5. Connect the negative test probe to its base, again the center leg. Like before, touching the collector and emitter legs in turn should give a reading in the range of 0.6 to just over 0.9 volts for each. Swap the positive test probe for the negative one, and touch the free negative probe against the other legs in turn. When connected to TR5's collector, as it is now, the meter should give an open circuit reading. When connected to the emitter, a reading of around 1.2 volts is normal. Ordinarily, a PNP transistor, like TR5, should read open circuit when tested like this, but other connections in the Spectrum's power supply circuit mean that doesn't happen. In an issue 4S spectrum, TR5 is in a slightly different location. Its center leg is its base, and it can be tested in the same way as I've just shown you. The 4S circuit board has provision for using two different types of transistor for TR4. If the transistor is installed in the outer set of pads, as this one is, then it is connected just as TR4 was in the test I've shown you, that is, its center leg is its base terminal. However, if it is installed using the pads nearest the keyboard connector, then the base terminal is the one nearest the rear of the circuit board. The middle one is its collector, and the one nearest the front is its emitter. It should be tested in the same way as I've just shown you, but keeping in mind that the base is now the upper leg instead of the middle one. If you are familiar with using the diode test function for testing transistors, then the key thing to remember is that no diode junction of TR4 or TR5 in circuit should ever show less than a single diode forward voltage drop, however it is biased. An incorrect reading on one of these tests probably indicates a faulty transistor, but the only way to be certain is to remove the transistor and test it out of circuit. If any of the tests shown in this video have failed, you absolutely should not connect power to your Spectrum. It almost certainly has a fault, and you could easily make the problem worse. If you found no faults, then it's probably safe to connect a power supply to see whether it works. If you've got a bench power supply with a current limiting feature, then I recommend you use this at first. Set it for 9 volts, limited to about 750 milliamps. When connecting it to the Spectrum, remember that the center pin of the input connector must be hooked to the negative side of the supply. Also keep this in mind if you are not using an original Spectrum power supply. Most generic replacement power supplies have the wrong polarity and will damage a Spectrum. On switching on, the current limit may become active while capacitors charge, but if it remains engaged for more than a few seconds, turn the power off immediately. Something is wrong. If you turn on the Spectrum with the upper case removed, you can check for the presence of 5 volts, -5 volts and 12 volts at the lower RAM chips on the same pins as used in the resistance measurements earlier. Do this as soon as you've turned the power on. Leave looking for a video signal from the computer until later. As before, connect the common terminal of the meter to the heatsink, but this time make sure it is set to measure voltage. If any of the voltages is not correct, switch the Spectrum off straight away. While making these measurements, take care not to slip and short one of the power connections, otherwise you could cause a fault when there was none to begin with. I hope you found this information helpful, and that you've now got a working ZX Spectrum to enjoy. And if it's not working, perhaps at least you've made the job of repairing it easier.